How are you? I'm Dr. Sanjeev Goel, and you're listening to the Peak Human podcast. Today's talk is about cell senescence, autophagy, and epigenetics. It's going to be hosted by a close friend of mine, Ryan Smith from TruDiagnostics. They run an amazing test on measuring your biologic age called the TruAge test. So I hope you enjoy and look forward to your feedback.
Hi, everyone. Thank you all for joining today. This is Ryan Smith of TruDiagnostics. And today I'm happy to have Dr. Sanjeev Goel here with us today. I'm going to give everyone a few more minutes to log on before we start the presentation. So to just be just a few minutes, but we appreciate you joining and are looking forward to talking about senescence, autophagy, and epigenetic aging. My name is Ryan Smith, Vice President of Business Development at TruDiagnostic, and really excited about tonight's webinar because we have a colleague and friend of mine, Dr. Sanjeev Goel, who is a physician and integrated medicine physician in the Toronto area, and has been, I would say, a colleague that has definitely taught me a lot. You know, whenever these new things are happening, such as plasmapheresis or new senolytic strategies, he's always one that teaches me a lot about what is happening and what his clinical experience has been. And today we couldn't think of a better webinar topic than updating on some of the things that we're learning about senescence and autophagy and senolytics. You know, this is a fastly growing area, and you know, all of these are related to different hallmarks of aging. So you know, today a lot of what we know about senescence and autophagy and senolytics are separate from what we know about epigenetic aging, and we're definitely trying to bridge that gap. So this talk might not have as much about sort of its references to epigenetic aging, as we're still trying to make those connections. But nonetheless, this is a very important topic in aging, and we're happy that you joined us today. I know that a lot of other conferences are going on, and so if you all have any questions, we can always use the chat features or the Q&A features on the Zoom links. I'll try and compile them toward the end so that we can ask the questions to Dr. Goel. And with that, Dr. Goel, thank you so much for joining. I'll turn it over to you.
Perfect. Thank you so much, Ryan, for the kind introduction. And yes, I'm really looking forward to talk to you about senescence, autophagy, senolytics, and epigenetic aging, because this is a hugely changing field, and I think it's you're hearing a lot about it in the news these days. So it's quite interesting, and I think you're going to enjoy it. At least get an appetite of what's out there, and you can then further your own reading. So I'm a physician practicing in the Toronto area. I run a longevity practice. And I'm really getting excited about cell senescence. So that's why I wanted to do this presentation for you all. So we can come back right to this. Is a very landmark paper by Lopez Oten in 2013, which is now brought forward this now universally accepted way to describe the aging process. These are all processes that are known to occur during aging, but it's unclear if any of them are the initial root cause. But we do know they seem to interact with each with each other. Dr. Kirkland, James Kirkland, an expert in aging research, like to describe actually four main aging mechanisms, because we're trying to get towards a unified aging framework. These are inflammation or inflammaging, macromolecular damage, such as DNA damage, mitochondrial dysfunction, epigenetic changes, telomeric loss, protein dysfunction. Number 3 would be stem cell and progenitor dysfunction. And then number 4 would be cell senescence. And so these processes of aging all lead to the phenotypes of what we see for aging, such as the geriatric syndrome of frailty, sarcopenia, immobility, and mild cognitive impairment. The chronic diseases such as, cardiovascular disease, cancers, dementias, arthritis, diabetes, and then decreased resilience, the ability to respond to the environment and adapt to the environment, such as problems with infection. That's why we see elderly people have problems with COVID infections, more chance of delirium, slower wound healing, recovery from injuries, and so on and so forth. So that just kind of sets the background of what we understand about how aging happens. And you can see it's a very complex process, and it's been traditionally broken down so many different processes, and we're trying to come together with more of a unified theory of aging. But we're going to focus mostly on cell senescence now, and so I want to talk about that. So we do know what causes a cell to become senescent. We think there's multiple factors. It's not even just one thing. It could be that the telomeres are becoming so short that the cell is unable to divide further. Mitochondrial dysfunction, dysregulated nutrient sensing, loss of proteostasis, epigenetic changes, and genomic instability. So changes in the DNA, and so that basically makes it a situation where the cell is unable to divide further, and then that cell, we're going to talk about it further, releases what we call SASP that then cause other cells to join in that same senescent state. And we do know that the number of senescent cells is directly related to the phenotype of aging. So the more number of cells that you have, the greater the aging process has proceeded. So what is cell senescence? I did talk a little bit about it, but basically it was first discovered in the 60s that there was a finite number of divisions that a cell could undergo, and that's about 50. By it's called the Hayflick limit. And so what happens is that cells will stop at exit the cell cycle at some point and enter into a usually irreversible, can be reversible state where they are unable to divide any further. And like I said, that the causes can be shortened telomeres, mitochondrial dysfunction, DNA damage. And this cell senescence is not necessarily always a bad thing. It can be potentially a very useful thing for the organism, and that's why it's evolved to be there. But as this talk is about how cell senescence can be a negative aspect, and we do know it contributes to aging. So what happens is that in about 30 to 70% of senescent cells produce a pro-inflammatory senescence-associated secretory phenotype. I know that's a mouthful, but it's called a SASP. And these SASP exert paracrine and endocrine effects, meaning that they affect the cells around them, and as well as send signals through tissues far away from them. These senescent cells accumulate in multiple chronic diseases, such as obesity and chronic kidney disease, and long-term persistence of senescent cells and their SASP disrupt tissue structure and function, having a deleterious effect on the cells around them, as well as systemic effects such as increasing inflammation, potentially even being oncogenic or carcinogenic. And it's interesting that the actual amount of cells, even a small number of 10 to 15% of senescent cells in a primate is sufficient to cause tissue dysfunction. So it doesn't need to be overwhelming majority, even significant number of 10% can cause that. What research has shown is that transplanting senescent cells into mice models actually causes disease and aging at a specific threshold. And this threshold is lowered if the animal is older or already has a high senescent cell burden. So that's quite an interesting study that we're able to do to actually prove that adding senescent cells to a healthy animal actually causes disease and aging. So I've kind of talked about this already, like what are the triggers of cell senescence? You can see this telomere dysfunction, could be an activated oncogene. And in the short term, this is a good thing because tumors get suppressed. We're limiting tissue damage because the cell's not dividing further. But in the long term, there is an aging of the tissue and potentially even cancer. And what can happen is that one of the reasons that a cell can exit a senescent state is when they're able to actually escape senescence and actually start dividing uncontrollably, which is actually cancer. The important part about this slide is just say that it's a gradual process. It doesn't happen immediately. A cell doesn't just start from healthy cell to become a full-blown cell that's releasing a lot of SASP and so on. It takes, I believe, could take about 3 months. So there's first initially early signs of senescence that then become late senescent cells that are triggering aging and more damage and releasing SASP. It's important, I think I did mention that there's good versus bad senescent cells, but of the senescent cells, 30 to 70% actually release SASP, but not all SASP is bad. SASP does serve some useful functions. It's used in actually recruiting, macrophages and immune cells to come heal wounds. But the problem is that when there's a chronic release of SASP, then that's when the damage starts happening, and that's when we start seeing aging. A chance of cancer starts increasing, and so on and so forth. At this point of this slide, just to say that I like this part, that to understand that there's a multiplier effect, that there's a feedback loop, that the more SASP gets released by a cell, it sends it, it basically feeds back, and even the cell releases even more SASP and recruits cells around it to release SASP. So when we have all this, I guess that we're going to be moving on to what do we do with this. And so we have really two options. We can either remove senescent cells through autophagy or prevent the formation of new senescent cells. And primarily today, we're going to be talking about removing senescent cells. There really hasn't been too much understanding about how we can prevent the formation of these types of cells. So autophagy is one of those processes that actually, your body actually has this process to remove senescent cells. And mitophagy refers to the process of removing, senescent mitochondria or damaged mitochondria. And so this homeostasis, the cellular homeostasis, is finally controlled by this process called autophagy. And even in a healthy situation, there's a small amount of autophagy always happening. But this process gets more efficient during stressful events to the organism, such as starvation or fasting and growth factor deprivation. And so what happens during autophagy is cellular components become sequestered into lysosomes, delivered to lysosomes, and they're degraded by lysosomes. And this plays a very crucial role in maintaining cellular homeostasis, and is precisely regulated, because if it's too much autophagy, that can easily lead to a wider death of the organism or tissue. So one of the key roles of autophagy is to maintain essential cellular activity, even under limited nutrient availability. It's really a way for the organism to adapt to stressful conditions while still being alive. And therefore, autophagy is tightly controlled by two nutrient sensors, mTOR and AMPK. mTOR, as you may or may not know, is known as the mammalian target of rapamycin, it's a protein kinase. And basically, it senses nutrients. It's activated by a nutrient-rich environment, whereas AMPK also senses cellular energy, and it is more activated in a nutrient deficient environment. AMPK, this go into a little bit of technical stuff here, phosphorylates ULK1, which is one of the main inducers of autophagosome formation. But this ULK1 is also regulated by mTOR. So all you can see here is that there's a balance between AMPK and mTOR that's very important to maintain the health of the organism. What we do know is that, caloric restriction, fasting, exercise, these mechanisms stimulate SIRT2 and SIRT1 gene different animals, which basically lead to longevity by probably stimulating these pathways of the AMPK and autophagy mechanisms. So let's just talk a little bit about measurement, because we know the senescence is happening, but how do we measure this, especially as clinicians? We don't really have a good measure at this stage. DNA methylation markers, looking at epigenetic aging, probably looks like to be something we can use right now, because it is correlated that the DNA methylation age is correlated with the senescent age, number of senescent cells. I suspect that as time goes on, this will get better. There is a mitotic clock. I know that TruAge is now TruDiagnostics is now made available. if it looks at the number of dividing cells. So if there's a high number of cells that have been dividing, then that could be a flag for cancer and potentially other dangerous diseases. I suspect if the corollary is that if we have a low number of dividing cells, then perhaps we could be saying that there is greater senescence happening in the organism or the human. And if there's also lower number, if you have excessive proliferative cells, then that potentially also means that you have less stem cells available because of stem cell depletion. Maybe at the end we can ask Ryan his opinion on this, but this is what I could make out from it. So what are senolytics? So senolytics are a new class of agents which eliminate senescent cells, meaning they come from the words senescence and lytic, which means destroying. And so there's apparently about 10 pro-survival pathways that are interlinked within these cells. And these senolytics target these pro-survival networks to, basically disable them so that the cell can then, be destroyed through apoptosis without affecting other healthy cells in the organism. This is a bit of a complex pathway, just to say that this is how autophagy happens, and I think I'll probably pass through that. Same, and so mitophagy is very important as well, and there's we have an understanding of how important that is as well. So the landscape of senolytics at this time, there's about 100 different senolytics being investigated, about 30 different companies pursuing research in this field, and research has shown that they've already shown that they're been useful in preventing, delaying, and alleviating multiple age-related chronic diseases. Most of the research has been in animals, preclinical research, primarily mice. But there's been some research in humans, though the numbers of people are small, and I'll be talking to a couple of those studies. We're going to be talking, I'm going to try to go through these, just, some of them on a cursory level, some more detail. They're not all of their true senolytics, but some, they are being used in longevity compounds, for example, NMN and resveratrol act in slightly different mechanisms. But many of the senolytics are actually flavonoids. You'll see that as we go through it. First one I want to talk about, because this is the most well-known senolytics. It's called quercetin. It's actually found in food, berries, apple peel, and datacinib, which is a cancer rejection drug. So Dr. Kirkland and colleagues from Mayo Clinic did a human trial for over 3 weeks. They looked at idiopathic pulmonary fibrosis patients, and they noticed that those patients had improved respiratory function. They were able to walk for longer. They had increased walking endurance, gait speed. And what they did was that, so they looked at a study. In the second trial, they looked at chronic kidney disease and diabetes mellitus, and they pulsed the doses of the datacinib and quercetin, because it looks like if we give constant doses of these type of supplements or drugs, we can actually cause damage. So the idea is that to give pulse dosage of these chemicals, that that we would see benefit. And in the study, they actually saw benefit in that way. So basically, these pulse doses reduce senescent cell burden and also reduce the number of side effects. And they were able to show that the SASP actually decreased in these patients. So these chronic kidney disease patients, there wasn't necessarily an improvement, reversal of the disease, but they were able to measure that the SASP decreased. So the next big one that, the Kirkland group is also working on this as well, is called quercetin. It's another naturally occurring flavonoid found in strawberries, apples, grapes, onions, and cucumbers. And they're also looking, similar to quercetin, it's actually very similar in molecular structure to quercetin, but it seems to be even more powerful So we'll see where that goes with this study. Toxophalin is another flavonoid. So I kind of put the flavonoids all together, and it seems to have multiple benefits across so many different systems. And the longevity piece is just, we don't even, it's not only acting through the, the senescent pathway, there may be other ways that toxophalin is working. Betinin is a pigment of red beet. It seems to have very high radical scavenging activity, and I couldn't find any specific research on its senescent activity, but I thought it would be useful for you to see that. Bergamot is a citrus fruit native to Italy, shown to improve lipid profile, but it seems to have also can alter the function of AMPK. And so that seems to be its effect on how it affects cell senescence. So let's look at NMN. NMN is not a true senolytic per se, but a compound that's gained a lot of attention for its potential use as a longevity promoting agent. NMN is known nicotinamide mononucleotide. It's one of the main precursors of NAD. And NAD, as you know, is an essential enzyme for various critical cell functions, including metabolism, DNA repair, cell growth, and survival. So NAD, as you know, is extremely important for energy production. The uptake of NAD varies across tissues, but we see a decline in NAD with age. This fall in NAD levels has been attributed to reduced synthesis and increased consumption, with the latter increasing degradation of NADA, so CD38. So basically, CD38 increases, and we see NAD levels drop. So basically, what they found was that long-term 12 months oral administration of NMN was associated with improved insulin sensitivity. And this is again in mice, but in humans, unfortunately, we have not seen that. There was just one study where they noted that there was improved insulin muscle sensitivity, increased glucose uptake into the cells, but they were unable to show any other benefit to humans. It could be that the dose needs to be increased, or the duration of treatment needs to be increased. In these studies, human studies, only 500 milligrams a day of NMN was used. So we can see here, we have different strategies for boosting NAD levels. Here are the precursors such as NR and NMN. There may be other ways to do it, but primarily this is what's gaining a lot of favor these days, and it has a huge potential range of benefits for NAD increase that have been seen in animals. So resveratrol is extremely well known. Dr. David Sinclair talks about it. You probably heard about that. It's a polyphenolic compound found in grapeseed, peanuts, and berry fruits. Has a huge number of health benefits: anti-obesity, cardioprotective, neuroprotective, anti-tumor. But the problem with it is that it seems to have very low bioavailability, but it seems to be acting by activating STIR2, which seems to mimic the effects of caloric restriction. So similar to what I mentioned before about autophagy and so on. So it seems to act like a calorie mimetic agent that enhances the longevity of the animal. Oops. Pasteuristilbene is related to resveratrol. It's the same class of molecule. So you can see here, it's a stilbene. Again, has multiple effects, just like resveratrol. So this compound has become quite famous. I think it's in the TruNiagen compound that they're mixed with NR. Let's look at spermidine. Spermidine has become, it was actually discovered in sperm. That's why it gets its name. It's a naturally occurring polyamine that increases autophagy. This study by Schroeder and al., a study in mice, showed increased hippocampal and mitochondrial function, aged mice, signs of improved cognitive performance. And Drosophila model, increased mitochondrial function was abolished when the autophagy promoter was knocked out. So that's kind of important to show that it's working through an autophagy model, because when they were able to knock out the autophagy promoter, the effect of the spermidine went away. There is a large scale prospective data showing that higher dietary spermidine intake is linked with a reduced risk of cognitive impairment in humans. So it seems quite promising. I think you're seeing a lot about it in the news. Luteolin is another one that seems to have a lot of effect on. They're talking about it's very cardioprotective molecule. Apigenin is related. It's actually, there was a study looking at a combination with resveratrol, and it showed it's also a flavonoid as well, and it showed strong anti-inflammatory activities. But basically, the co-treatment of apigenin with resveratrol increased the levels of the apigenin by 2.4 times. And so in that way, it seems that these two molecules could be acting synergistically. Alpha ketogluteric acid is an intermediate in the Krebs cycle. It may extend human lifespan. It's been shown to show improvements in muscle growth after surgery. And Dr. Brian Kennedy's group has been looking at the effect of AKG on longevity. They've probably been looking at mice right now, but I believe they're doing a human trial to see what the effect of AKG is on longevity. And I believe they're looking at DNA methylation as a biomarker to see if it's making an impact. EGCG is actually extract from green tea. And it seems to, like I mentioned before, that there's importance between the mTOR and MPK. There needs to be a balance, and this EGCG basically changes the balance, so it delays apoptotic cell death by upregulating autophagy. So green tea extract seems to have a lot of positive effects on health. There's lots of studies on that. 3,4-DMC induces autophagy through activation of transcription factors. And so I think you can see that there's a lot going on with these supplements, but we still don't know about the short and long-term side effects of these supplements. We don't know what type of cell types will respond to them, and which is the best combination of these senolytics. Like I mentioned, certain dutasterib and quercetin seem to be additive effects because they go after different types of senescent cells. We don't know what the impact of these senolytics on healthy cells, because, like I said, some senescent cells are important. They carry out a very important function, and we don't know what would happen if we clear out senescent cells in the heart or brain, because there's not so many new cells that are dividing in those organs. So we don't know what would happen. Slight little plug, I've come out with a supplement at Peak Human called Fasting Pro. It has, these 12 ingredients, pretty much things that I've mentioned before. We put it all together into one supplement, and I'm free for any questions.
Perfect. Thank you so much, Dr. Goel, for the presentation. And just a few things before we open up questions, if I might as well. I just want to give maybe even a larger view of some of the really exciting things that are happening in senescence from a research perspective. These are going to be a little bit further away than many of these products, which are applicable now from a nutrition standpoint. But even already, we know that there have been some really exciting trials in animal studies, which have, for instance, been able to have vaccines for senescent cells. cells, where they've been able to activate things like invariant natural killer T cells to get rid of almost all senescent cells. But there are obviously a lot of questions as it relates to senescent cells, as Dr. Goel mentioned, in different types of tissues. The brain, for instance, or others, and most people don't even know that we're even born with up to 6% of senescent cells already in our body. And so, as Dr. Goel had mentioned as well, this is a process which is both functional at some times, and obviously as we accumulate these with age, a little bit less so. And so these things are coming out, and we're learning a lot more about this process now. I should also mention that from a pharmaceutical perspective, many of you all might be familiar with the company Unity Biotech, who was doing some really advanced trials for senolytic medications for things like osteoarthritis, which didn't meet their clinical endpoints. But this still tends to be one of the fastest and growing areas of research and development for aging. And some of the phenotypic effects have been very, very positive. Going back a little bit into the peptide world as well, I always like to mention the FOXO4 DRIs. That is sort of a senolytic product, and you can look at the mice before and after to see exactly how it affected that phenotype. So with that being said, this is going to continue to be an area we learn a lot more about as more and more research comes on. But right now, I think that these potential nutritional ingredients are something that are absolutely applicable in the clinic, and using combinations of them are things that we've seen to be effective. With that being said, I would love to answer any questions. So please put these in the comments as we go along. Dr. Goel, just to start off, I think that we had one question here about how do you use both, or how would you consider, at least clinically, using both human growth hormone as well as other senolytics and or rapamycin for people who wish to use both interventions? Do you typically cycle that? And if so, what are your typical cycles?
Yeah, that's a superb question, and I've been thinking about that a lot as we're learning more and more about senescence and autophagy. Definitely, as the name suggests here, we're promoting. This is meant to basically promote the calorie mimetic state or calorie restricted state in fasting. So, but human growth hormones, and effectually, it's basically activating the other pathway, which is the mTOR pathway. So I don't think these things should be done together at the same time. I normally tell my patients that you may do 6 weeks or 2 months of growth hormone or CJC or morellin, so something like that. But then you need to give your body a break and then move into the autophagy promoting phase by fasting or using these types of supplements like the senolytics. So I would say something like a couple of months on, a couple of months off. That's what I'm telling my patients. Or if we're looking at rapamycin, that's why rapamycin is dosed on weekly basis, because it seems to also be it's inhibitor of mTOR. So we probably don't need to take growth hormone on the day that you're taking rapamycin, because they seem to be working against each other.
Definitely. And Dr. Goel, to go forward on that a little bit more, can you also comment on how you might use your product, which included a lot of the ingredients that you're talking about, in relationship to fasting? Would it be better to take those type of supplements at night or in the morning? And just sort of talk about the overall strategy with some of those other sort of nutritional ingredients.
Yeah, we're actually doing a clinical study looking at comparing fasting pro. Comparing the fasting pro to actual intermittent fasting, and we'll be doing epigenetic age methylation testing to see what impact it's having. But my thoughts are that again, if you're doing like a heavy muscle building program, then you probably should take a break from fasting pro or even fasting. But I'm recommending my patients to do this on 3-month cycle. Do 3-month cycle of fasting pro, take it every day. If you're doing a heavy workout, maybe skip the dose that day, and then take a little break from it, and then come back to it. Something like how even if you look at fasting programs such as Prolon, which is only one time per month, a week per month, you can see that everything's happening in cycles or pulses.
Definitely. And to elaborate that just a little bit more on maybe some of those epigenetic measurements we've seen, I will say that, one of the algorithms that we run and is one to consider one of the best is that Dunedin pace of aging marker. And that one seems to be very sensitive to caloric restriction and fasting. And obviously that is hopefully a good sign, is that caloric restriction is one of the most well-vetted sort of longevity strategies. And so with that being said, I think that we would probably anticipate that doing some of these other products, which increase some or sort of act as calorie restriction mimetics, would have some positive effects on some of these as well. And as Dr. Goel mentioned, although there's not a good test for senescence yet, there might be some coming out. And also we have seen epigenetic age-related change with senolytic strategies, particularly 6 months of the dasatinib and quercetin. So the dasatinib and quercetin we imagine are helping reduce those inflammatory markers by clearing those senescent cells, and then probably having a positive overall effect on epigenetic age. And so we do have a few more questions, I think, Dr. Goel, that I'll try and field to you. And one I think goes into NAD levels in particular, and how do you measure NAD levels, and how do you know if it's worth supplementation with NAD?
Yeah, I don't measure NAD levels. I don't know if there is a test that measures NAD levels that's available easily for me. Again, I tell people to, I'm recommending NMN because it seems to be convert better to NAD, and then I'm recommending people take 500 milligrams a day.
Definitely. And I should mention that, we've done some clinical trials where we are trying to measure NAD, and it can be very, very difficult. I don't know many people using it clinically because most of the testing that has been done in some of those larger clinical trials is very, very expensive. And traditionally, companies, for instance, like TruNiagen will use NAD metabolome type testing. And I'll put that metabolome in the chat so you all can sort of see what many of these markers are, but these are obviously very, very robust. There are over 18 different metabolites. I don't know anyone using it clinically, but I know that is sort of what a lot of the researchers are using. And as I think Dr. Kleeper had mentioned in the chat, Genfinity does measure NAD as well. And so I went ahead and put those NAD metabolome markers there as well. The person who does a lot of that testing is someone you might know from social media, Charles Brenner from the City of Hope, who was one of the creators of TruNiagen. They do that metabolomic testing at the Center of Hope in case anyone is interested, but it might be a little bit too expensive and plasma inaccessible for clinical practice. And so
you were mentioning there is a company that's doing NAD testing, which is called Genfinity.
Yeah, Genfinity in Georgia. And again, I'm not sure. I don't know a lot of the details about that testing, but it's run by Dr. Shi. We can, if anyone has any questions, we're happy to connect them with Dr. Shi, who can answer some of those questions. So I know we have a few more questions as well. So one is, have there been any observational data that you know that has collected the adverse effects of senolytics on healthy cells?
No, I haven't seen any data on that. Ryan?
No, I haven't either. Unfortunately, and as I mentioned, I know that obviously, and as Dr. Goel, I think you mentioned as well, we know that some levels of senescence is a good thing, but I'm not sure, about a total ablation of those cells and what that would mean or what it does to healthy cells as well.
I was just listening to a podcast by Kirkland, James Kirkland. He was basically really worried. He said that likely there will be side effects. We just haven't seen it yet. I mean,
yeah,
I suspect.
Yeah. Sorry, Dr. Goel, I didn't mean to interrupt, but I wanted to mention as well that I'm also hearing, different types of strategies, in that regard too, between sort of the pulsing versus a more consistent approach, particularly to things like Fisetin, some of those supplements. Like, is it better to do a once weekly, 1,000 milligram dose, or is it better to do more consistent daily dosing? And I think the answer is, right now, at least, we don't know. I think the rationale for the pulsing has been that it gives your body to help clean up some of the debris that you would have from increasing apoptosis, and help your body sort of deal with some of those other cellular debris and increase autophagy. But I don't know at the moment if one, or if anyone else knows that one type of research is beating the other. And then, so Dr. Goel, I know we have one other question as well, and it can be sort of a two-part question. Do you know that any other tyrosine kinase inhibitors would work like the dasatinib and quercetin do? And then, in addition to that, are you aware of any research on NAD and autophagy?
No, I'm not aware of any other tyrosine kinase inhibitors. I looked for the NAD and autophagy and I couldn't find it. So I still thought it was important to talk about it today because we're talking about autophagy. I may talk about NAD, even though we're talking about autophagy, but I couldn't find any specific link.
Definitely. Okay. Perfect. And then, I think that one of the other questions would be sort of about, I'm going to expand the question just a little bit. But the question was, can a 25-year-old use Fasting Pro to mimic fasting, or just to be optimum? But I think it answers maybe even a larger question, which is, would you have age limits for the types of senolytics or things that might accelerate the fasting process or caloric restriction, which you would use in office? Any clinical guidelines for some of those procedures?
I think that when you're hitting into the 30s onwards, probably a good idea. I think when one stops growing, then I think these caloric mimetics become useful. So I think we want to start slowing down that aging process once we stop growing. So I think for longevity that makes sense. Maybe not hit it super hard at the young age, but I don't think it's a bad idea to start already the cycles of some autophagy promoting lifestyles or supplements.
Yeah, definitely. And I see another question here as well toward the end, asking how does one obtain dasatinib? Are you using a pharmacy for it, Dr. Goel?
I know I'm not. I'm prescribing rapamycin, but no, dasatinib, no, I'm not. And I suspect, in Canada, we could just write a prescription, but I haven't done it because I wasn't sure that we should necessarily do that in humans till we have more studies. But
Definitely. And I should mention as well that in our dasatinib and quercetin trial, we did get it from TaylorMade, but I know that there are several other compounding pharmacies making it as well. And I should mention definitively that if you try to get the brand name Spiracel, it is incredibly expensive, thousands of dollars. And so really, I think the only route to do it in a cost-effective manner for not outside of the label use of cancer, I think would be through a compounding pharmacy. And so I would definitely check with compounding pharmacy, but even at compounding pharmacies, those doses at 50 milligrams can be very inexpensive, traditionally less than, $30 or $40 a month. If you're doing a 50 milligram administration 3 times monthly. And so it is still accessible, but you definitely might get sticker shock if you look at the Spiracel.
Ryan, what was the dosage protocol you're saying in the study that they're doing right now on dasatinib and quercetin? Like, what are they doing?
So we've completed that trial and are now publishing the results, hopefully including that new Yale senescence algorithm, which has been trained off of only one type of senescence, which is replicative senescence. And so the dosage there that we used for the clinical trial was mimicking some other clinical trials which have gone on, but there were very, very few. And so it was a conservative protocol at right around 50 milligrams of dasatinib and 50 milligrams of quercetin. And I should mention as well that there are different levels and brands of quercetin as a supplement ingredient as well. There are many, many different versions now, like things like curcumin, which are much more bioavailable. There are now supplement ingredients of quercetin that can be up to 500 to 1,000 times more bioavailable than regular quercetin. And so theoretically, some of those more bioavailable methods might be better, but we just use the traditional quercetin. at 500 milligrams and then 50 milligrams of the dasatinib. And that was on days 1, 2, and 3 of each month for 6 months. And we did see as a whole a positive epigenetic change over the course of 6 months, but we only did 20 patients. And it actually had, technically we did 22 patients, but 2 dropped out due to side effects, particularly headache and nausea. And so again, it was a pretty high dropout rate considering the low sample size. And so I can completely understand maybe some of the hesitation, but with that being said, everyone else handled it pretty well, and even most of the other side effects were non-existent. And so I know that was probably a long-winded explanation, but it was a 6-month course, 3 times per month at 50 milligrams and 500 milligrams.
Perfect. Thank you.
Yeah, definitely. And I think that the only other question that I see at the moment, it goes to sort of a true age question, which is once we have a baseline true age for biological age and one does a 3-month program a couple times, when should someone check true age again? And this is a question that is always changing as the algorithms get more specific and more accurate. And so typically I would not have said more than once every 6 months or once every year, just due to the margin of error of this testing. We want to make sure that what we're measuring is the actual age change and not any noise. And so I still wouldn't recommend any more often than once every 6 months. I think once every year is also completely fine. And with some of the newer algorithms, particularly with the Dunian pace, I think that those are much more sensitive and can be done in smaller amounts of time. And so I'm really excited to look at the data with, for instance, fasting a little bit quicker. And so that one, we're actually coming out with a lower price point test, again, to sort of tease in the next 3 months, we hope to have a test that's under $200 that will be able to measure the rate of aging. And so you might be able to use that for a more immediate feedback if you needed to. But traditionally, I would say once every 6 months to make sure that it's accurate enough to actually get a real signal. And so I hope that is helpful. And
that's as precise. That's very precise. The Dunedin pace of aging result is a very precise test.
Correct. Well. Yeah. So we measure sort of precision in talking about if we measure the same sample twice, how close are those values together? And that one has definitively been the most precise, and it's also the most responsive to intervention. So if we look at, for instance, things like caloric restriction, it's able to capture change due to traditional measurements like caloric restriction better than any other algorithm, including Grim age. And so as a result, that is the one that we would say is it can be a little bit more accurate and diagnose this age changes in a quicker amount of time. And because it's also an sort of an instantaneous measurement, one that's not overall biological age, it is something that's able to tell you a change more quickly. So it's both more precise and more responsive.
And Ryan, you alluded, I alluded in the presentation to the mitotic clock. So I would think that if there's less proliferation of cells, wouldn't that mean more senescence?
So I should say that is a difficult I should say clock. That clock has one fundamental problem in understanding its relationship to senescence, which is that we're measuring 2 different types of tissue. We're measuring essentially lymphocyte tissue, and then we're measuring other less proliferative tissue. Lymphocytes obviously can replicate very, very quickly, and so whenever we're measuring the blood, we're measuring cells that both go quickly and slowly. And so the one thing that has been correlated to is cancer, which is that the higher the amount of proliferation or stem cell divisions, generally the more increased risk you have for cancer. And so that mitotic clock is until we have a myeloid versus lymphoid deconvolution method, it's going to be hard to relate that to senescence. But right now we know at the moment, if you're scoring in the high percentiles there and you're at sort of over 65 or 70, it could mean that you have a higher risk of developing cancer. And so it's already clinically applicable. Every cancer that's ever been tested has increased mitotic rates. So we know that this is a high correlation, and really we hope that people can use it in our testing as a gut check to sort of say, hey, does this person need to be more preventative or do more preventative types of analysis in their clinical practice to worry about cancer? And some of those types of actions might be preventative screenings, or they can be things like the GRAIL testing, to do liquid biopsies. And so if you have someone who's scoring, in the top 10% of that over the age of 65, we would recommend maybe doing some follow-up testing.
So just sorry, I just want to jump in there. So this means that one likely has some cancer cells. Like if the proliferation is already happening, right? It's not like precancers or something.
Correct.
What you're
Correct.
putting in,
Yeah.
there may be some small cancerous cells already there.
Yeah.
Okay.
Definitely. And yeah, definitely. And again, I think that we're going to learn a lot more lessons, especially as more of these algorithms come out related to, some of these other things. And so Dr. Goel, I see a couple other questions I want to get to you, which are again, some other good ones about, is fasting pro helpful for weight loss or is it just for optimization in aging?
We didn't focus on weight loss particularly, but I mean, if we can again be mimic the caloric restriction that happens in fasting, then potentially there could be weight loss, but we're not studying that. We're looking really at longevity.
Definitely. Okay. And then in addition to that, I see a question from Dr. Kleber about does NAD increase the SASP cell function? And then another question we can do as a follow-up about FOXO4.
Yeah, I didn't see anywhere that NAD increases SASP function. I don't believe so. Potentially, probably would decrease it, but I don't know, Ryan, if you have any further knowledge on that, but I didn't see anywhere about that.
Yeah. I'm afraid I don't. I do know that. So Dr. Kleber's next question though is about is the FOXO4 DRI specific to bad SASP cells? And Dr. Goel, I don't know if you've had any clinical experience with the FOXO4 DRI.
No, I haven't. We haven't got that peptide. Difficult to get it here in Canada, but it's very expensive. But maybe you could speak to it.
Yeah, well, so the FOXO4 DRI is working on, sort of that P53 pathway. And so it is I would say, targeting cells via sort of interacting in their apoptosis mechanisms. And so it should be clearing only senolytic cells. However, I know that for many with the FOXO4 DRI, they are concerned that it is too effective and that it might be lysing too many senolytic cells. But it is also only acting on one of the what we call the SCARPs, like the basically the anti-apoptotic pathways. There are multiple different types. And that's, I think, why a lot of people like Fisetin. Because although FOXO4 is only working on one type, that P53 pathway, the Fisetin can almost be a broad spectrum, almost like a broad spectrum antibiotic. It works on many of those different anti-apoptotic pathways. And so I think that's why people are really excited about the Fisetin. I've heard James Kirkland say that as well. But and again, I don't know about the NAD and the SAF study, but I do know that, so Dr. Kleber, I'll be happy to distribute that afterwards. I do know that there are some of the mitochondrial peptides that theoretically are thought that might increase levels or burdens of senescent cells through just helping cells survive when they maybe shouldn't.
No, it looks like the reason why there's the dutacinib and quercetin combo is because they target different pathways, and so I think different cells. Yeah,
I wasn't sure sort of the pathway of the quercetin, but I think that that makes sense as well. And then I think that we have one more question, Dr. Goel, before we wrap up, and I think that is do any of these ingredients have any impact that on the non-human cells within us, such as the microbiome or pathogenic viruses or other bacteria?
I mean, in my research of looking some of these compounds up, many of them seem to have some effect on the gut microbiome. But I mean, I wouldn't be able to tell you anything very more specific than that. But it looks like some of the positive impacts of some of these are through the gut microbiome.
Perfect. Yeah. Well, great. And I know that we will be able to have these slides and this recording sent out following the webinar. So if anyone has any other questions, you can always email them to me. I know that I would like to distribute some other things like Dr. Kleber's study that he referenced to make sure that we don't have any gaps. And Dr. Goel, if you have any questions for him, please let me know, and I'd be happy to forward them along. Dr. Goel, thank you so much again today for speaking about this subject. I know that we'll be excited to have you back on as we complete some of the other clinical trials that you're working on, both with the Fasting Pro as well as the plasma apheresis. And so look forward to having you back on for another webinar. And thank you so much again.
Well, thank you again for having me, Ryan. Thank you.
Yeah,
Thank you,
appreciate
everyone.
it.
I hope you enjoyed today's talk on cell senescence, autophagy, and epigenetics. If you want to view the full podcast, then please go to my membership site by clicking in the link below, and I hope to see you there.